Processing through Agisoft Metashape can be a complex task, and anyone you speak to will give you their point of view as to how it should be done. This is a no-frills, start-to-finish process that will get you results at the end of the day, and I'll explain a little bit about each of the settings as I go about them and why I choose to run them the way I do. The first step, of course, within Agisoft Metashape is to add your image files. You might have them as individual files or a folder that contains all of them. Whatever the case, go ahead and add them into your project. When adding the images, the software might ask if it's a single scene or a dynamic scene. In this case, it's a single flight with a drone. Therefore, I will select the single scene option when it appears. Once your images are loaded into your project, you'll want to turn on the camera icon so that you can see your image positions. Confirm that everything looks as you expect it should be. In this case, I will tilt the view and you will see how all the images are captured at the same elevation. It's preferable to do this to get a more consistent result, though it is not essential. Also, having a grid pattern like we see here helps us capture each and every side of the area that is being surveyed. We also see that all the image metadata has been loaded in as well, coordinate values, positions, etc. We'll then want to align the images. We have a few options when aligning the images, and we could go from the fastest to the slowest, being low to high settings. I like to use the high settings. Here, because we have the ortho information, we're going to select the source data as the reference pre-selection, and in this way the software won't have to estimate where the images fall. Looking at our advanced settings, I find it's best just to use the default number of points that the software estimates. Once the alignment is complete, turn off the cameras so that you can see your tie points clearly and evaluate them for accuracy as well as for noisy points below the surface. It's at this stage that some people might just carry on and build their dense cloud or their models. However, it's very important that we filter these tie points. As you'll see, there are a lot of erroneous points. The cleaner we have our tie point list and the resulting camera calibration, the better each of our products are going to be down the line. That includes our dense cloud, our models, our DEMs, and our Orthoimage. So observe, please, the process here in filtering the tie points. It's a little tiresome, but really important to get the best result, and you'll only need to run through this process once. Be sure as well to save your project as you go along. You don't want to have your computer crash and have to start at the beginning again. To filter the tie points, we want to choose the Model tab at the top of the screen and then go to Gradual Selection. There are 4 options in this drop-down menu, and we'll start with the option number 2. Allow it to analyze your points. Then by moving the sliding bar, we will see how many points of a lower precision or accuracy the software will want to select. I find generally a number 20 or below is the target point over here. The better the camera you have, the lower the number you'll be able to select. Observe in the bottom left corner of our window how many points are being selected. We don't want to remove too many, but also not too few. You can also tilt your point cloud to make sure that the points that are being selected are those that are below the surface or up in the sky. Once you've chosen your number, hit the delete key and then go and optimize your camera. It will refine the parameters before we move on to the next step. As you can see here, already we've been able to clean out a lot of the erroneous points that were below the surface. Once the camera optimization is complete, we'll then want to move on to the second step of 3 of our type point filtering process. In order to do that, we want to select Model, Gradual Selection again, and this time from the drop-down menu, we select the first option. The value that it presents here is related to the number of pixels that it has calculated. We always want to target half a pixel or less, sometimes 0.5, sometimes I like to go a little bit lower, 0.45 in this case. Again, select the setting, apply it, and then we'll want to delete those points and optimize the camera calibration once more. Once that step is complete, we'll choose our third option. From the drop-down menu, we want the bottom selection. This time we want to attempt to achieve about 10% of the active type points. Observe again in the bottom left of the window as we move the slider bar how the selected number of points changes. Target more or less 10% of the points, select the result, accept it, delete those points, and for the last time we will optimize those camera parameters. If any points remain after this process, you might want to pan through the model, select them manually, and delete them, thus ensuring your type points are all clean so that when we move on to the following steps, you're starting from the best basis point. Do a final optimization and save your project. Once that is done, we can move on to building the dense cloud. When building the dense cloud, I like to select the high setting as well. Medium and below will be faster, but for quality, we choose the high setting. In terms of how many points we want to filter, an aggressive amount of filtering could remove too many valid points. So choose either mild or moderate, keeping in mind that we will filter the dense cloud later on to clean up any rogue points. That process could take a few hours depending on your specs, but once it has completed, activate your dense cloud and pan through the model to take a look at the result. You'll also want to observe the number of erroneous points that have been created, and keep in mind that we will be filtering these a little later on. Here we can see quite a number of points below the surface. These typically will appear on very reflective surfaces or water. When we created the dense cloud, we also kept the option active that would allow the process to compute the point cloud confidence. This is very important as this is the value that we will be using to start the filtering process. To filter the point cloud, use Tools, Dense Cloud, and we want to filter by confidence. 0 is the lowest confidence, and 255 would be the maximum amount of confidence. If we scale our point cloud from 0 to a low number, 3 to 5 perhaps, we are able to observe all of the lower quality points. Conversely, if we scale from 3 or 5 up to 255, we can keep all the higher quality points in the view. This won't, however, delete the points. We will have to do that step manually. You might want to run this process a few times, just observing what the optimal number is for your project. Keep in mind it will vary based on the camera that you are using. A more expensive and higher quality cameras tend to have fewer erroneous points. The quality of your capture could also play a role here, so it's not just a price or quality of camera scenario. Take this time to observe your point cloud very carefully and filter it, going through each step nice and slowly, making sure that you choose the optimal setting. You don't want to have to spend a few hours recreating the dense cloud again. Once you are happy that you have found the correct setting, filter by confidence, going from minimum to the setting you want, 3 in this case, and apply. Then select all of the points on the screen and delete them. Once you have deleted them, we can go and reset the filter, which will give us our point cloud that now only contains those good value or high confidence points that we have filtered out. Look through your point cloud one last time, confirming that all the erroneous or rogue points have been cleaned up. If they haven't, you might want to manually delete them. Here I am just aligning and cleaning the edge data out because it's unnecessary for my project. Always remember to save your project after having applied any new settings or run any new processes. Now that we have a clean point cloud, we can go about building our mesh. There are 2 options to build the mesh. One can be from the point cloud and another can be from depth maps. In this instance, I'm going to select the point cloud option first with a high number of faces. Remember, the number of faces will use a lot of memory if you choose the high setting. So if you do fail on the high setting, choose a medium or low setting. However, you will also lose some of your model quality. We're also selecting the 3D model in this case, as it is the optimal solution for modeling. Later on, we will attempt to create the 2.5D model for Orthoimage production as well. Once your model is built, zoom in and take a look. You will now note the 3D nature of this model. However, when looking at specifics such as the trees and buildings, we do see that they appear to be blurred. This is because we have not yet produced the image textures. We'll move on to that step next. It's a good idea to find something that is relatable before creating the textures, such as a building. This way, when the textures are produced, we'll be able to discern the quality of our result and rerun the process if necessary. When building the texture, we have a few options again. Typically, the automatic settings of Agisoft can be accepted. However, the resolution at the bottom, you might want to change this based on the size of your project. If we keep that number low, it will generate a few textures and therefore still be of a low quality. If that is the case for you, increase that number and rerun the process. We can see in this case that the textures are not optimal and there are some errors. Therefore, we will recreate the model from the depth maps and reproduce the textures as well. Often the depth map method will create a nicer looking model. When you create your dense point cloud, select the option to keep your depth maps so that you don't need to recreate them in this step. When we observe this model, it does appear to be of a higher quality than the one we created from our dense point cloud. This is the one we will use for our following steps. If you're happy with it, go ahead and build your textures again. In this case, I will decrease the number of textures because of the failure we had last time, from 48 down to 24. This setting can be adjusted as your project requires. Allow the process to run, and then take a look at the results. In this case, we have been able to produce relatively high quality textures that are now overlaid on the model. If you are not happy with your results, you can rerun the process, increasing the number of textures. If you are satisfied with your output, save your project and move on to the next step. The next step for us will be to build our DEM. We have a few options again in building the DEM. We can build it from the dense cloud, from the tile points themselves, or from the mesh. In this case, we'll build it from the dense cloud, but keep in mind that the dense cloud is unclassified. So in essence, we are creating a digital surface model, DSM, which will include the trees as well as the ground, the house, and the cars. Later on, we will look at filtering those elements out. We can now take a look at the digital elevation model that we have created. And as we anticipated, we do see that the house, the car, the trees, and other elements are present on this model. For many purposes, this is required. However, you might also just want to create a digital terrain model where we will need to first go ahead and classify that dense point cloud to include only the ground points. As a first step, use the tools to classify the dense cloud to ground and select Agifold's default settings. This isn't a very time-consuming process, so we can run a few iterations if it is required when we are not happy with the outputted results. Once the process has completed, go ahead and rebuild the DEM. This time we expect a DTM as the result, without the trees, the building, the cars, etc. included. When building the DEM, select only the ground point class, otherwise it will rebuild the same DEM as we had originally. When the creation is complete, observe the result. We now have a far cleaner DTM, however there are still a few spikes in the model. We will need to reclassify those ground points. Before reclassifying the points, it may be a good idea to observe the dense point cloud and see where the erroneous points are. Using this approach with the automatic classification method can also help us to iron out any issues we might have before going about creating the digital elevation model. In this instance, the brown points are classified as ground, the white points are unclassified, and the pink points have been classified as low points. I'm going to go ahead and rerun this process. But before we do that, it might be a nice idea to turn off all the point classes apart from ground and observe the result that we received from the first iteration. When we do this, we can see that there are points that sit within the forest that was to the north of our project area. These are the points we want to target for cleaning. We will now rerun the automated classification process, making small settings to the standard Agisoft ones. Again, turn off the unneeded point classes and observe the result. In this case, still not optimal, so we run the process again. The result is a little better, but not quite what we're after. There are only a few points that remain, so here we are manually cleaning out the points that we know will interfere with our DEM. Take your time to do this carefully, not quickly, as you see in the video. Now we can recreate the digital elevation model and observe the result. In this case, apart from one spike, we almost have an optimal digital terrain model. For the sake of the video, I shan't clean out that erroneous point, but we'll move on to the next step, which is creating contours. We are able to select any contour interval that we choose, as well as the elevation that we want to create contours for. In this case, I will use the maximum range for the project area and use the automated setting of 1 meter intervals. Once completed, zoom in and take a look at the contours. Overall, Agisoft seems to have created a good set of contours. You can export these contours into other software packages to filter them, to refine them, to clean them, or to change their coloring. The next step is to create our orthomosaic. In this instance, I shall use the digital elevation model as the base for our orthomosaic. This isn't necessarily the optimal option to choose, as we will see in the result. We have the ability to create an orthomosaic from the digital elevation model, as well as the mesh that we created. Keep in mind that the mesh we created has 3 dimensions. That too is not optimal for our orthomosaic processing. So we will want to refine that model before creating our final orthomosaic. Before we do that, let's observe the orthomosaic that we have created and examine its quality. Here on this building, we can see a few artifacts that will need to be addressed. In general, other areas of the orthomosaic seem to have been created well enough. However, for an optimal orthomosaic, we'll want to create a 2.5D mesh. This mesh will follow the trees, the building, the car, and ground level, but it will triangulate straight down to the ground and not create a rounded effect that we get from the 3D model. The 2.5D model is the correct option to choose when producing the orthomosaic, though you might not want to use it for presentation purposes of the model alone. Once the model is completed, take some time to observe it to understand the differences between the 2.5D and the 3D model. Note in this case how the model goes from the top of the tree straight down to the ground with a vertical line. The same can be said for the building. Once we observe and understand our 2.5D model, we are going to recreate our orthomosaic and look for the differences we are able to achieve between the 3D and the 2.5D models. Select the mesh in this instance and reproduce the orthomosaic. Immediately we see a drastically improved result. The building looks far straighter as we expect it to be, and the other elements that previously looked good are still good and even improved. And there you have it, an end-to-end process flow in Agisoft Metashape. There are more settings that we could review and we could change. These are just the ones that I have found work for me within my process flow. Thanks for watching the video. If this has been helpful, please like and subscribe. It really does help the channel.